Imagine a nation not just building, but redefining the very limits of what's possible. A country where engineers aren't just designing structures, but challenging the laws of physics itself. Prepare to journey into a realm where ambition takes colossal form, where rivers are redirected, oceans are spanned, and the heavens are heard like never before. These aren't just feats of engineering, they are monuments to audacity, each one a testament to human ingenuity pushed beyond all conventional boundaries. What secrets do these megaprojects hold? And how did they leave even the most seasoned engineers speechless? Then don't forget to like, subscribe, and hit the bell icon, so you never miss an adventure into the unknown. Let's explore the secrets of our world together. Rising above the swirling currents of the Yangtze River in China's Hubei province, the Three Gorges Dam is not just a colossal concrete structure. It is a symbol of a nation's ambition, technical ingenuity, and the complex trade-offs between development and sustainability. As the largest hydroelectric power station in the world, this megastructure embodies the intersection of energy, engineering, environment, and ethics, and continues to spark both admiration. Completed in 2012 after nearly 2 decades of planning and construction, the Three Gorges Dam is a staggering feat of modern engineering. It stretches over 2.3 kilometers, 1.4 miles, across the Yangtze River and towers 185 meters, 607 feet, in height. This dam, unrivaled in scale, houses an installed generating capacity of more than 22,500 megawatts, making it the single most powerful hydroelectric facility in the world.
We're in one of the 3 very large powerhouses of the Three Gorges project. In this 700-meter-long room here, you can see 14 of the large turbine generators. Then beyond this one, a kilometer away is the second powerhouse, and then beyond that one is yet another powerhouse which will be underground in the rock on the far side of the river. Each one of these generators cost about $50 million.
Its main purpose? To power China's rapidly industrializing economy with cleaner energy. In a country long dependent on coal, the most polluting of fossil fuels, the dam offers an alternative path. At full capacity, it can produce over 100 terawatt-hours of electricity annually, enough to supply tens of millions of Chinese homes and industries. This not only diversifies the nation's energy portfolio, but also contributes significantly to carbon emissions reduction, a priority for a country increasingly aware of its environmental responsibilities. But electricity generation is only part of the dam's mission. For centuries, the Yangtze River has been both a lifeline and a menace. It has nurtured civilizations along its fertile banks, but it has also unleashed catastrophic floods, with some incidents, like the 1931 flood, claiming hundreds of thousands of lives. One of the dam's most critical functions is flood control. By regulating the river's flow and retaining excess water during rainy seasons, the dam significantly lowers the risk of downstream flooding. This capability has potentially saved millions from devastation, particularly in populous cities like Wuhan and Chongqing. It has also allowed planners to reduce the need for extensive flood dikes along the river, freeing up land for agriculture and development. Constructing the Three Gorges Dam was not merely a building project. It was an orchestration of human will, financial muscle, and cutting-edge engineering. Over 40,000 workers were employed, and the project consumed an estimated $28 billion, an astronomical figure, yet one that reflects the ambition of the enterprise.
And this is our mighty River Dordogne here on the beach. Now, you can't just pour concrete into the middle of a river. They wanted their dam here, but in order to get one dam, they had to build 3. First of all, a temporary dam goes in here, what's called a cofferdam. That stops the river flowing. You can't just stop it.
Inside the dam's heart lies a system of 32 main turbines, each weighing hundreds of tons and rotating with near-silent efficiency. Its massive ship locks and the world's largest ship lift allow vessels to travel upstream and downstream, preserving the Yangtze's role as a critical artery of Chinese commerce.
You can see there is the amazing power and force you can get out of water under pressure. And that's what we use to lift big, heavy stuff.
However, this engineering marvel came with a steep human and cultural cost. To make way for the dam's 600-kilometer-long reservoir, over 1.3 million people were forcibly relocated. Entire communities, some with centuries-old histories, were submerged. Temples, ancestral homes, ancient towns, and over 1,000 archaeological sites were lost beneath the rising waters. Compensation schemes were often criticized as inadequate, and many resettled villagers struggled to rebuild their lives, particularly in unfamiliar urban environments. From an environmental perspective, the dam's impact has been immense and, in many respects, troubling. The Yangtze is a river of rich biodiversity, and the dam's presence has disrupted its natural flow, fragmented habitats, and interrupted fish migration routes, threatening the survival of native species. Perhaps the most tragic symbol of this disruption is the Yangtze River dolphin, Beijing, now widely considered extinct, a direct consequence, many believe, of habitat degradation and river traffic. Sediment, once naturally distributed by the Yangtze to nourish downstream ecosystems, now settles behind the dam, leading to erosion in the river's lower reaches and coastal areas. These changes threaten the long-term sustainability of fertile agricultural regions and contribute to coastal recession in the Yangtze Delta. Geologically, the dam also raises eyebrows. Scientists have warned that the weight of the enormous reservoir may increase seismic stress along fault lines, potentially triggering earthquakes or landslides in the surrounding regions. Indeed, several minor tremors and geological incidents have already been linked to the dam's presence. Despite the formidable challenges and controversies, the Three Gorges Dam remains a bold expression of 21st century identity. Assertive, technologically sophisticated, and relentless in its pursuit of development. It is part of a broader narrative in which China has redefined what is possible in infrastructure, pushing boundaries with high-speed rail, megacities, and cross-sea bridges like the Kong-Zhuhai-Macau Bridge. The dam exemplifies the go big or go home philosophy that underpins much of China's recent growth. It's a statement to the world that China not only builds the biggest, but also dares to undertake what others might consider too complex, too expensive, or too risky. In the end, the Three Gorges Dam is more than just concrete, steel, and spinning turbines. It is a layered story of progress and loss, power and displacement, protection and disruption. It invites admiration for its technical audacity and inspires critical reflection on the social and ecological costs of modernization. As China continues to shape its future, the dam stands as both a monument to its achievements and a reminder of the responsibility that comes with wielding such transformative power. The question is not just what the dam has built, but also what it has buried. In that tension lies the true legacy of the Three Gorges. Having mastered the formidable challenge of taming a powerful river for both energy and flood control, China's engineering might then turn its attention to conquering the open sea, bridging vast stretches of water to unite critical economic centers. Spanning the shimmering waters of the Pearl River Delta, the Kong-Zhuhai-Macau Bridge, HZMB, is not just a bridge. It is a bold declaration of vision, unity, and engineering audacity. At approximately 55 kilometers in length, it is the world's longest sea-crossing bridge and tunnel system, a sprawling network of concrete, steel, and innovation that physically and symbolically connects Hong Kong, Macau, and Zhuhai. More than a transportation link, the HZMB is a metaphor for the integration of cities, economies, and ideologies in a rapidly transforming region. Before the HZMB, travel between the three cities was fragmented and inefficient. Ferries across the delta waters were time-consuming and often subject to weather conditions. Overland routes, though possible, involved lengthy detours. What the HZMB offers is a dramatic change. Travel time from Hong Kong to Zhuhai is reduced from about 4 hours to just 45 minutes. For businesses, logistics companies, and commuters, this is nothing short of transformative.
I think it is very important for the cities in the Bay Area, including Hong Kong, Macau, and Zhuhai, because every city, is very near to each other, but at the same time, the traveling time has been so long. So basically, each city has its own limitations.
This bridge acts as a physical and economic artery in the Greater Bay Area, one of China's most vibrant economic zones, which aims to fuse 11 cities, including Guangzhou and Shenzhen, into a mega region rivaling Silicon Valley. By bringing Hong Kong's financial expertise, Macau's tourism and entertainment industry, and Zhuhai's manufacturing prowess into closer proximity, the bridge accelerates the region's push toward economic integration. The sheer complexity of the HCMB demands recognition. This is no ordinary bridge. The structure comprises 3 cable-stayed bridges, with elegant spans that rise like modern cathedrals above the sea. A 6.7-kilometer undersea tunnel, the first of its kind in China, enables unimpeded passage of massive cargo ships along one of the busiest maritime routes in the world. 2 artificial islands, each serving as critical nodes for the transition between bridge and tunnel, were constructed using advanced land reclamation techniques. This hybrid design wasn't a flourish of creativity, it was a necessity. The Pearl River estuary is a chaotic mix of deep waters, powerful currents, and dense maritime traffic, all of which make conventional bridge building impractical. Engineers had to invent solutions in real time, pioneering floating caisson techniques, modular segment construction, and systems to manage wind loads from super typhoons and seismic activity. Beyond its structural brilliance, the HZMB carries profound political and cultural symbolism. The bridge links 3 jurisdictions with distinct legal and administrative systems under the One Country, Two Systems framework: Hong Kong and Macau as special administrative regions, SARs, and Zhuhai as part of mainland China. By physically linking these separate territories, the bridge underscores Beijing's intention to knit together fragmented political spaces into a cohesive national identity while maintaining the unique statuses of each region. It's not just about transportation, it's about shaping a shared future where economic collaboration coexists with political nuance. This symbolism has sparked debates, particularly in Hong Kong, where some critics view the bridge as an instrument of political assimilation. Still, many others see it as an opportunity, an opening for shared growth, cultural exchange, and deeper interdependence. The HCMB's journey wasn't without controversy. Environmentalists raised concerns over its impact on the fragile marine ecosystem, particularly the endangered Chinese white dolphin, which inhabits the waters near the bridge. Construction disturbed natural habitats, altered sediment flows, and introduced underwater noise pollution. Mitigation strategies were implemented, including ecological compensation areas and habitat monitoring programs. But the long-term environmental footprint remains a subject of study and concern.
We must first build the island, so it is on the critical path to speed up the construction and also to save the environment, reduce the dredging amount for the seabed. Then we use the cylinder to form an island. And by using these cylinders,
critics also question the project's cost efficiency, with a final price tag exceeding $20 billion, and its initial low traffic volumes led to speculation about underutilization. However, with increased awareness, expanding regional industries, and integrated customs systems, usage has steadily grown, particularly for cross-border cargo and tour groups. The HZMB is not an isolated feat. It belongs to a larger family of ambitious Chinese infrastructure initiatives that are reshaping global perceptions of possibility. Like the Beijing Daxing International Airport, whose starfish-shaped design and hyper-efficient layout redefine airport architecture, the bridge embodies a new era of super infrastructure, where projects are not just functional, but visionary. These projects serve dual purposes. They solve real logistical challenges, while also acting as cultural and diplomatic symbols. The HZMB, for example, presents China as a force of unity and progress, capable of envisioning and executing long-term development strategies that blend ambition with practicality. As the morning mist lifts from the delta and traffic begins to hum across the HZMB, the bridge stands not only as a marvel of engineering but as a bridge to a reimagined future. It invites questions and dialogue about the price of progress, the meaning of unity, and the balance between growth and preservation. Yet, one thing is certain: the Hong Kong-Zhuhai-Macau Bridge is a physical poem in concrete and steel, a sweeping stroke across the waters that links history with possibility, ambition with achievement. It reminds the world that infrastructure can be more than roads and bridges. It can be a nation's heartbeat, echoing far beyond its foundations. Following its vast land and sea expanses, China's architectural ambitions stretch even higher, culminating in iconic structures that reshape urban skylines and connect the globe. In the 21st century, China has redefined the language of infrastructure, pushing boundaries not only in size and speed, but in vision. Two of its most stunning symbols, the Beijing Daxing International Airport and the Shanghai Tower, stand as complementary pillars of that vision, one on the ground, orchestrating the future of global connectivity, the other in the sky, twisting its way into history as a vertical ecosystem. Each project is an ode to innovation, environmental consciousness, and a new era of Chinese urban imagination. Nicknamed the Starfish for its 5-point radial structure, Beijing Daxing International Airport, PKX, is more than just an airport, it's a spatial revolution. Designed by the late Zaha Hadid, the airport is an embodiment of organic design meeting aerospace efficiency. With its smooth curves and sweeping canopies, the terminal seems to rise naturally from the ground, blending architecture with aerodynamics. At 700,000 square meters, the single terminal structure is the largest of its kind in the world. Yet its genius lies not in its enormity, but in how it shrinks the experience for passengers. Unlike traditional airports where long walks and multiple transfers are the norm, Daxing allows passengers to reach any gate within 8 minutes from the central courtyard, a feat accomplished through its symmetrical petal-shaped design that minimizes distances without compromising functionality. From check-in to boarding, the user journey is carefully choreographed. Facial recognition, AI-driven security checks, and automated baggage handling create a seamless flow, while large skylights channel natural sunlight deep into the terminal, reducing the psychological stress of indoor travel and cutting electricity use.
So here they've kind of done it both ways. I mean, so sure, you have the fancy facial recognition technology, which should make life easier in important ways, important high-tech ways.
Daxing is also a pioneer of green aviation infrastructure. The terminal is equipped with rainwater collection systems, photovoltaic solar panels, geothermal heating and cooling, an intelligent energy management system that regulates temperature and lighting based on real-time occupancy. These innovations contribute to Daxing's ambition of being a carbon-conscious transportation hub, aligned with China's broader environmental goals. Strategically located between Beijing, Tianjin, and Hebei, the airport is designed not just as a terminus but as an intermodal hub, seamlessly connecting high-speed rail, expressways, subways, maglev trains planned. This interconnectivity reflects a vision of integrated urban mobility, where an airport is no longer a detached destination but the heart of a high-speed, low-carbon transportation network. Rising 632 meters into the clouds, the Shanghai Tower is not only the tallest building in China, but a beacon of vertical innovation. Twisting a full 120 degrees as it ascends, its spiraling form makes it appear to dance with the wind, a design that serves both aesthetic and structural purposes. The twist of the tower reduces wind loads by 24%, drastically lowering material requirements and costs. It also creates multiple rooftop platforms, some of which house sky gardens, verdant breaks in the verticality that provide natural ventilation and aesthetic calm for office workers and hotel guests. With 128 floors, the tower accommodates corporate headquarters and co-working spaces. The J Hotel, one of the highest luxury hotels in the world, sky lobbies and public observation decks, retail and cultural venues. Green rest zones and cafes are embedded throughout. Every corner is designed with human experience in mind, proving that skyscrapers can be both monumental and humane. The Shanghai Tower isn't just tall, it's smart. It features a double-skin facade, creating an insulating air pocket that reduces heating and cooling needs by up to 30%. Rainwater recycling systems and grey-water reuse. Wind turbines at the top, powering external lighting. A high-performance damping system to withstand earthquakes and typhoons. It has received LEED Platinum certification, making it one of the world's most sustainable super-tall buildings. In a country grappling with rapid urbanization, the Shanghai Tower reflects a new philosophy, grow upward, not outward. It is a city within a city, allowing thousands of people to work, live, meet, shop, and relax, all without leaving the building. Elevators powered by magnetic levitation zoom at 20.5 meters per second, making vertical travel as fast as urban commuting. Beijing Daxing International Airport and the Shanghai Tower, though structurally different, are spiritual siblings in China's infrastructure evolution. Both projects challenge the limits of traditional design while embracing sustainability. Both reimagine how people move through the air and across urban space. Both are symbols of a China that does not merely build big, but builds smart. They reflect a China that is not only investing in monumental scale, but in human-centered design. A country using infrastructure to weave connectivity, climate action, and community into its cities. Just as these megastructures redefine what is possible on Earth, China's eye is also turned skyward. The Fast Radio Telescope, nestled in the mountains of Guizhou, listens to whispers from distant galaxies. In this trilogy of grand vision, the airport, the skyscraper, and the cosmic ear, China tells a story of ambition unbounded by ground, gravity, or galaxy. Together, they form an arc of progress, linking the infrastructure of today with the aspirations of tomorrow. Having seamlessly connected vast swathes of land and sea, and redefined urban and aerial infrastructure, China's gaze now turns far beyond Earth, with an ear of unprecedented sensitivity poised to listen to the deepest whispers of the universe itself. In a remote, forest-cloaked basin in Guizhou province, nestled within a naturally occurring karst depression, rises a feat of cosmic ambition, the 500-meter aperture spherical telescope, better known as FAST. With a diameter of 0.5 kilometer and a dish area equivalent to 30 football fields, FAST is not merely the largest single-dish radio telescope on Earth, it is humanity's most sensitive ear tuned to the whispering secrets of the cosmos.
The FAST telescope is currently the largest single-dish radio telescope in the world.
This titanic scientific instrument represents not only an engineering marvel, but a monumental leap forward in our ability to study the universe. Through its colossal aperture and revolutionary design, FAST redefines how we detect and interpret signals from deep space, unlocking new doors in astrophysics, cosmology, and even the age-old question, are we alone? What makes FAST exceptional is not only its scale, but the intelligence of its surface. The telescope's 4,450 triangular aluminum panels are mounted on a dynamic cable system that allows the surface to morph in real time, adjusting its curvature to create a perfect parabolic shape for focusing radio waves from any region of the sky within a 40-degree zenith angle. This active surface technology sets FAST apart from all previous radio telescopes, which are typically fixed or limited in their tracking capabilities. Unlike its predecessor, the Arecibo Observatory, which relied on a stationary reflector and suspended feed platform, FAST's robotic feed cabin, suspended by cables and controlled by servo mechanisms, can be positioned with millimeter precision. This allows unprecedented agility and sensitivity, enabling FAST to conduct deep space surveys with astonishing accuracy. Its remote placement far from urban electrical interference allows it to detect faint radio signals that would otherwise be drowned out. The karst valley serves as a natural shield, isolating the telescope from human-made noise and effectively turning it into a celestial sanctuary for signals older than time itself.
Complete. What we don't see is also super interesting. A mandatory radio quiet zone that stretches more than 3 miles in every direction right from here. Scientists want to listen to very faint radio waves coming from millions of light years away, not from someone's cell phone down the road.
Since going operational in 2016 and opening to international scientists in 21, FAST has already begun to rewrite what we know about the universe. Over 800 new pulsars have been discovered, dense, rapidly rotating neutron stars that emit beams of electromagnetic radiation. The telescope has detected repeating fast radio bursts, FRBs, mysterious millisecond-long pulses whose origin is still largely unknown. It has played a key role in mapping neutral hydrogen gas, the most abundant element in the universe, critical to understanding galaxy formation and dark matter distribution. FAST has contributed to the SETI, Search for Extraterrestrial Intelligence, initiative, analyzing narrowband signals that might be indicators of intelligent alien civilizations. Each of these discoveries not only extends our scientific reach, but also humbles and excites the human imagination. With FAST, we are no longer just spectators, we are active listeners in the vast cosmic orchestra. FAST is not just a scientific instrument, it is a national emblem. For decades, astronomical discovery was led predominantly by Western powers. With FAST, China signals a shift in that cosmic balance. This telescope is a powerful demonstration of China's capability to build world-leading scientific infrastructure, attracting top-tier researchers from around the globe and positioning the nation at the forefront of deep space exploration.
Actually, astronomy is a very open science that encourages collaboration from all over the world. And China has always been very open in astronomy and physics and some other sciences.
The telescope also represents a new model of international cooperation, with data increasingly shared with global research communities and invitations extended for collaborative work in astronomy and signal analysis. While FAST gazes outward into the ancient past of distant galaxies, China is also grappling with the challenges of Earth, particularly the imbalance of water resources between its southern and northern regions. The South-North Water Transfer Project, another of China's monumental infrastructural undertakings, reflects a complementary philosophy: to engineer balance and sustainability not just in knowledge, but in life itself. Where FAST listens for the origins of the universe, the Water Transfer Project seeks to sustain the origins of civilization, clean water, agricultural vitality, and livable environments in arid northern regions. Together, these two colossal endeavors illustrate a national ambition that bridges the celestial and the terrestrial, science and society, discovery and survival. In many ways, FAST is a mirror turned outward. It reflects a deep and eternal curiosity. What is out there? Who else might be listening? What echoes remain from the dawn of time? Yet, it also reflects something inward, a story of a civilization that dares to dream bigger, build bolder, and listen deeper. A civilization that, even in an age of noise, dares to preserve silence to hear the most ancient truths. From a quiet valley in Guizhou, China, now speaks to the stars and listens for their reply. Even as China reaches for the stars with its cosmic ear, it simultaneously undertakes an equally monumental task on Earth, a historic re-engineering of its own landscape to deliver vital resources and ensure national balance for generations to come. The South-North Water Transfer Project, SNWTP, is one of the most ambitious hydraulic engineering efforts in human history. A bold, multi-decade mission to resolve one of China's deepest natural imbalances, the stark geographic mismatch between water abundance and water demand. With the Yangtze River Basin in the south rich in water and the north parched by drought and overuse, this mega-project reimagines geography itself, redirecting the flow of nature to serve both survival and development. Stretching over 2,000 kilometers, the SNWTP is not merely a pipeline or canal. It is a national circulatory system, designed to transport over 44 billion cubic meters of water per year to some of China's most densely populated and industrially significant regions. It provides vital relief to metropolises like Beijing, Tianjin, and Zhengzhou, where water scarcity once posed a formidable threat to economic growth, public health, and ecological stability.
I could be one of the few people who could still walk inside this water tunnel. In Beijing, it stretches over 80 kilometers. It will transport some 2/3 of the total volume of incoming water from the south.
The SNWTP consists of 3 main arteries, each distinct in route, geography, and complexity. The eastern route revitalizes ancient canal systems, like sections of the Grand Canal, upgraded with modern pumping stations to lift water upstream through low-lying plains. Running over 1,150 kilometers, It supplies Shandong and northern Jiangsu, supporting irrigation and industrial water needs. The central route is the most operationally significant and politically symbolic. Originating from the Danjiangkou Reservoir on the Han River, a tributary of the Yangtze, it travels 1,400 kilometers north, crossing the Yellow River through massive tunnels, and reaches as far as Beijing. This route alone serves tens of millions, providing clean drinking water to some of China's largest cities. The western route is still in planning due to its extreme complexity. It proposes to divert water from the upper Yangtze tributaries in the Tibetan Plateau through rugged mountains into the Yellow River Basin, a logistical and environmental frontier that will test the limits of modern engineering. The project's execution involves cutting-edge technology, rivaling the scale and precision of space missions. Tunneling under the Yellow River, one of the most sediment-rich and unpredictable rivers in the world, was a near-miraculous achievement, requiring pressurized shield machines and adaptive design to navigate unstable geology. Many sections of the central route move water by gravity alone, with a delicate slope of less than 0.001%, made possible only through precise terrain mapping and millimeter-level elevation control over vast distances. In places where terrain defies gravity, gigantic pumping stations lift millions of tons of water daily, sustained by massive power infrastructure. Reservoirs along the routes not only regulate flow but also help prevent flooding, maintain water pressure, and serve as emergency reserves during dry seasons or maintenance closures. The SNWTP's impact on society is profound. Urban and industrial stability in northern cities has improved markedly. Agricultural productivity has increased in regions once plagued by dry seasons. Groundwater overuse, a crisis in many northern provinces, has slowed, allowing aquifers to slowly recover. Yet these gains come at significant costs. The environmental toll includes disrupted river ecosystems, particularly in donor regions like the Han River Basin. Altered water flows can affect fish migration, sedimentation, and downstream agriculture. Moreover, more than 330,000 people were relocated to make way for reservoirs and infrastructure, a move that, while compensated, has drawn criticism for social and cultural disruption. Maintaining water quality is another ongoing battle. Water traveling across thousands of kilometers can pick up pollutants, requiring constant monitoring and treatment. Ecological stability in both the donor and recipient areas must be carefully balanced, not merely engineered. Despite its challenges, the SNWTP embodies a uniquely Chinese philosophy of infrastructure, one that views natural forces not as immutable constraints but as elements to be harmonized with through design, effort, and vision. Rather than merely extracting from nature, the project seeks to reconfigure the flow of nature for mutual benefit, echoing ancient practices of water control that date back to Emperor Yu the Great. This idea finds a parallel in another staggering achievement: the Danyang Kunshan Grand Bridge, the world's longest bridge. Just as the SNWTP stitches together distant ecosystems, the Grand Bridge spans rivers, lakes, and cities, unifying an entire region through transport and trade. The South-North Water Transfer Project is more than a water pipeline. It is a river of stone, steel, and will, carrying not only water, but the future of China's northern heartlands. It is an enduring symbol of technological audacity, a reminder that the challenges of geography can be met with the courage to imagine and the power to build. As climate change intensifies and populations continue to swell, the SNWTP stands as a blueprint for large-scale resilience, offering lessons not just to China but to the world, about adaptation, sustainability, and the human capacity to mold the future drop by drop. China's monumental megaprojects stand as a testament to unparalleled ambition and engineering ingenuity, frequently eliciting awe and disbelief from global experts. From the Three Gorges Dam, a colossal feat harnessing the Yangtze's power while managing its destructive potential, to the Kong-Zhuhai-Macau Bridge, a network defying the sea to connect major economic hubs, these structures redefine what's physically achievable. Further showcasing this vision are the Beijing Daxing International Airport and Shanghai Tower, which merge architectural brilliance with cutting-edge sustainability. Meanwhile, The Fast Radio Telescope tunes into the universe's oldest whispers, and the South-North Water Transfer Project undertakes a monumental re-engineering of natural water flows. These endeavors are more than just infrastructure. They are powerful symbols of China's relentless drive for progress, innovation, and its assertive role in shaping the 21st century. If these incredible feats of engineering and ambition left you speechless, there's so much more to explore. Like this video, subscribe to our channel, and share it to help us uncover more mind-blowing projects that push the limits of what's possible. Your support keeps us going.